Okay, so I'm David Spergel. I'm the director of CCA, and the goal of this event is really multifold. Primarily, it's to introduce the new people to the rest of the CCA, introduce everyone to the new folks, get from them. And the second goal is to summarize where the groups are and where they're going. The second part is part of an activity that we'll be doing this year. The CCA will be turning 5 years old in September of 21. And as part of that process, we're undergoing an annual review with an external review committee. And part of that review will be our presenting to the external committee our understanding of what we accomplished in the past 5 years, or past 4 years, and then looking forward to what are the most important questions, what are the most important areas in which we see the CCA contributing in the next 5 years. And as part of that, I've asked the group leaders to talk about, and the senior leadership to talk about their vision of, in their area, of what the most important priorities are. So you'll hear as we go through the session, those stories interwoven with people's presentations. So let me introduce myself. I've asked everyone to to maybe mention some of the things they've done in the past few months as we've been persevering through COVID. For me, one of the things I've been doing and enjoying is bicycling around New York City and exploring for the 5 boroughs. I've not yet been to Staten Island and have made it as far as Westchester. My research interests at the moment have been primarily focused on cosmology, thinking about ways of applying machine learning. I'm involved in a bunch of big scientific projects. I'm active in ACT and the upcoming Simons Observatory, microwave background experiments. I've been one of the leaders of Roman Space Telescope. I've been thinking about machine learning applications to cosmology. Throughout my career, I've been thinking about dark matter candidates. That was my PhD thesis, and I returned to this topic episodically. And I've also been pretty actively engaged in science politics. So among the things I've done during these COVID days is I'm part of an informal group of scientific advisors working with Senator Schumer's office on developing plans and to implement this proposed enormous growth in NSF, quadrupling in its budget that's been proposed by Senator Schumer and Senator Young, and also trying to inform the Biden campaign about potential opportunities in science if it grows. So I'm happy to talk about that with people sometime, as well as the science. Next, I think, is Shirley.
Hi, everyone. This is Shirley. I'm Shirley Ho. I'm Cosmology Cross Data Science Group Leader. I'm in my office today. It's really nice to be back, I have to say. My COVID activity has been packing, moving, and unpacking the whole family with grandparents in tow 3 times since. When COVID first started, we moved to upstate New York thinking it would be a couple months. And then we moved to Vermont, realizing it would take a little longer. And then finally settled in Princeton right now, actually, just a couple weeks ago. And so hopefully we'll stay there for a tiny bit until, hopefully we'll be moving back to New York City soon. So I guess this is part of my COVID activity now. I also started to learn a lot about outdoor sports in Princeton, even though it wasn't something that I learned actually as a grad student in Princeton a long, long time ago. Okay, but now I'm learning a lot more actually. Research interest. Fundamentally, I'm an astrophysicist, a cosmologist. I like to learn about the initial conditions and contents of the universe, and that's really the goal, I think, being who I am right now as a scientist. Recently, I got really interested in using deep learning to accelerate simulations and develop these simulation-based inference techniques that I think apply not only to cosmology, I hope not only to cosmology, but many, many different fields. Also using new methods to discover new analytical relationships from simulations using deep learning and understanding how deep learning works, possibly using astrophysical data as a playground, I think would be very interesting. We don't know how it works, so it would be really nice to find a data set that is clear enough, has enough symmetry, and things that we understand enough to even try. How to inject ideas in physics into machine learning techniques, which is actually a very active area that people are trying to put in symmetry and conserve quantities to try to condition the network to learn better. So that's what I've been doing. Next slide. So the 5-year plan, here is a broad view of what I think we will try to do. And we are actually conducting a survey even within the group to see what the 5-year plan should be and how the structure should be for the group. But this is possibly what we want to do right now. And that's my personal view, at least as of today. We might actually keep updating as new ideas come up and new data comes up. So here's the current version. Want to build and deploy end-to-end simulation-based inference for larger structure surveys and CMB surveys and the crosstalk. So the surveys, such as the starting ones, will be probably Sloan Zero Sky surveys, BOSS, and Advanced ACT, and then we might look into PFS, DESI, LSST, currently called, and also Simon's Observatory. We are currently building critical analysis pipeline for Simon's Observatory and Advanced ACT already. And for some other surveys that we are significant parts of, such as SphereX, Euclid, Roman, and Rubin, we'd like to find new ways of analyzing them that aren't already done and already tested and tried 5 times already. And personal goal, maybe hopefully the goal of the group, if we can convince the whole group, is to become sort of de facto center for cosmological analysis using modern techniques in both statistics, deep learning, and computing. And I think there are interest in the group, and I'm really curious to see whether we can inject physical constraints, ideas, or maybe you call them wisdoms, into deep learning method development. And broadly speaking, want to impact the cosmological community and probably a wider scientific community by publicly releasing all the codes and simulation data. And after all, think deeply and be able to adapt as new data comes and new surveys comes out. That's it. Thank you.
Good timing there, Shirley. That was 1 second left, 5 seconds left.
Yeah, I guess it's me. Hi, I'm Jens. I hope you can all hear and see me.
I'm giving you 2 minutes, Jens.
Oh yeah, it's starting, right? So I'm just going for it.
You do it.
So yeah, my COVID activity has also been moving, so I can relate. I'm now talking to you from my new home in Princeton. I came here from Spain, and I'm just so glad that this window opened and everything worked fine for this transition. And now I'm really excited to start in Princeton as a postdoc and visit regularly at CCA to work there with Sasha Filippov on compact objects. Also during COVID, I've been writing my thesis, which has been a whole other issue, and I was glad that we had some time for other things as well. So I was in Germany at my parents' place for a long time. I haven't seen them this long in a row for many years, so that was great. We built a porch. I'm now back to sports, and everything's getting better after the thesis. My main research interest and why I'm excited to be at CCA is to ask the question, what if the physical regimes we have are not limiting anymore our numerical laboratories? So what we're doing is we bring these compact objects and their magnetospheres here to us, where we can measure what's happening in them and actually look at them. But we are very much confined to the different plasma regimes. So I, for example, wrote a force-free plasma code, which is limited to the highest magnetizations. And then every time particle physics comes in, the whole thing breaks down, and you cannot do much more about it. So I want to overcome this and set up a range of different laboratories to ask questions that are relevant, for example, to magnetars, so highly magnetized neutron stars, to black holes and accretion disk dynamics. So I've been working on coronal loops that accrete onto black holes, and there's a lot of reconnection questions missing to answer, and I hope to do so in the next 3 years. So if any of this has triggered you, just give me an email. We set up a call, and now I'm looking forward to hear from you all. Thanks.
Good timing, Jens. Jordy. Jordy in the house? Let's go to next slide. Juna,
Hello, everybody.
you got 2 minutes.
Yep. So my name is Joonas Nättilä. I'm now a joint postdoc between Columbia and CCA. I actually started already in January, but this is the kind of first introductory meeting. And so for my research, I'm basically working on astroplasma physics. And then from there, I'm doing large-scale kinetic and kind of multi-physics simulations, which you can actually see on the in the picture with the there on the left, and then the collisionless shock forming the top panels. With my current projects, like I said, I'm mainly focusing on accelerators in plasma physics, like collision plasma dynamics, including shocks, turbulence, particle acceleration, but then also doing computer science. And then finally, my kind of COVID activity has been for a long time now empirical hydrodynamics. So basically swim, and this has been actually quite tricky in the Corona times, like because of the indoor pools have been all closed. But at the moment we are still actually in Finland in our summer cabin, and we have the whole lake here to enjoy that. So that has been nice. I should be back to work, I think, in a few weeks. So glad to meet everybody there. Thank you.
Good, that was great. One thing I'll say is people are putting some questions up, and I think the way we'll do this is we'll keep going through the people, and then when we get to the break point, we'll ask questions. That way we can keep it rolling for now.
And people should also feel free to answer questions on Slido in sort of parallel mode.
Exactly. Good point. Selma, are you on the call? Selma. Oh, my session's not doing so good.
So Selma's going to be visiting us for a month.
Caleb.
But I guess it's not here.
I'm presenting for Caleb today.
Okay, good. 2 minutes.
Okay, I'm definitely not Caleb, but Caleb Wheeler was hired here at the CCA, and is actually contributing as an experimentalist at NIST, working remotely at NIST to help develop and finalize the detectors for the Simons Observatory. As you may know, every time you build a new telescope, usually either the camera or the detectors associated to that are the most complicated part, and they need a lot of effort, and Caleb is an expert on that, and so is working very hard in NIST, going through COVID with that, and hopefully will help getting us on the sky pretty soon. And yeah, that's it.
Okay, good. Next, Kadri. 2 minutes.
Hi, I'm Kadri. I'm one of the pre-docs here, coming from the University of Florida. So my COVID activity, near the beginning of the lockdowns, I bought a bass on a whim, and now I've had a lot more time over the past few months than I thought I would to learn to play. Found out that I actually really like that. I wasn't a musical kid growing up, but it's a lot easier to learn as an adult. My research interests are planet formation and exoplanet demographics. So right now I'm finishing up my master's project at the University of Florida. That's trying to see how giant impact driven atmosphere loss compares to photoevaporation, and what that would look like in a Kepler-like survey, and trying to see if we can tell the difference between the two. But here I'll be working on the effect of binaries on planet formation. We know that close binaries potentially destroy planet formation, and that well-separated ones seem not to do anything, but we don't really know what happens in that gap. And so to that end, I think for the 5 months that I'm here, I'll be working on the first part of that, which is how can we tell if a star is a given binary? That's kind of a thorny problem, and I'll be using Gaia data along with Spitzer photometry to try to be able to give like a probabilistic answer to that question.
Awesome. Awesome. There were comments about the band, but we'll come back to, or about the possible CCA band. Next is me. So I am my name's David Hogg. I'm at NYU as well as CCA, although this year I'm full-time at CCA. And I guess my codebug activity, aside from slow cooking, has been working on long-term writing projects. And one of those has made me think about like whether I should be doing some kind of podcasting or teaching online in some ways, since I'm not teaching this year. So that's something I've been thinking about. All of my research interests relate to computational data analysis. And I work across all astrophysical domains. I don't actually particularly have a favorite scale. I started out as a cosmologist, thinking about the global properties of the universe and the physical cosmology, like how structure forms in the universe. But I work at all scales all the way down now to exoplanets. I've even done a few things in the solar system. My current projects that I'm really excited about is I'm working on, with Megan Bedell and Winston Harris, I'm working on making observational projects more efficient. So how do you take an observational project and at fixed cost, have it deliver more science, or at reduced cost, deliver the same science? And that relates to a lot of projects, although right now I'm focusing on terra hunting, which is an exoplanet search project that we're involved in here at CCA using radial velocities. I'm working on building new tools for measuring large-scale structure that are, again, more efficient. They more efficiently use the information in the Hubble volume to measure the baryon acoustic feature or whatever you care about in large-scale structure. And I'm working with Adrian Price-Whalen to determine the shapes of the orbits in the Milky Way using chemical abundance measurements we have of stars. And then with Megan again and Lily Zhao, I've been working on calibrating spectrographs to make hardware systems more efficient at fixed cost or fixed number of photons. As you can see, I'm interested in kind of engineering aspects of data analysis a lot of the time. Next slide, please. The Astronomical Data Group has a mission statement, and this is not the mission statement. This is some 5-year plans that are related to our mission statement, and our mission statement is more general principles from which these derive. But I put up the plans because it's more about like what projects are available. And one of the things that I've just mentioned is that CCA is involved in a bunch of projects, which includes SDSS-5 and terra hunting, but also SphereX, Roman, LIGO, and maybe in the future LSST. We've been doing a lot with Gaia and Test too. So we're interested in hard data analysis problems in any of those kind of domains. And our domains keep growing with time as new people join. And we kind of adapt what we do to who's in the group. We're interested in new hard problems with data. And one new hard problem we've identified that might be exciting is transit spectroscopy, because it pushes everything that's hard about exoplanets with everything that's hard about spectroscopy. So we love that problem. Our kind of expertise is in mathematically rigorous approaches. So we're sort of, we are interested in things that have provable properties or working with the mathematicians. So we work with CCM here and actually mathematicians at NYU and all over. And we are very people oriented. The group is run by its members, and we think of it ourselves as a group, and we all learn from each other, and we try to build communities. And one last thing I should say is we're very focused on open source development, open source communities, and supporting open science in general, open data and open science. And I just made it within 4 minutes. I think that finishes the first round. So I think we have a moment here where we can ask questions. If there are people who want to upweight questions, I'm looking at the Slido, and we have several questions about butternut squash. If I go between the Slido and the chat, there's several questions about butternut squash, and there are oh, and there's a question from Stephanie about for Kadri about who he will be working with on these projects. So butternut squash.
Yeah, maybe we go with the other question because it's
You can't bring yourself to answer a butternut squash.
I can.
Brisket.
Yeah, you roast it and put it in a soup, for example. And yeah, I mean, the difficult thing is cutting it, then it's getting easier. Okay, and now Quadri maybe.
Quadri.
I'll be working with Dan for Mamaki, but this is this is way out of my comfort zone in general. I generally work with like in-body simulations for planet formation, so that sounds cool.
Ah, good. So you're a theorist coming to data here. Good, that's great. There was also several recommendations. Oh, so one question that came in is, Kadri, are you interested in AGN disk simulations, or are there connections between exoplanet simulations and AGN simulations?
I can't think of anything off the top of my head besides that disk physics are the same. But I've never really thought about AGN disk simulations.
Well, that's an interesting thing to do here because we have some experts here in that area. There are recommendations on the chat and on Slido about starting a CCA band with members of the astronomical data group throwing that in. So I don't know, something might have to happen.
Unfortunately, we all only play bass.
Oh, so it's an entirely bass band? Maybe Spergel can sing, so it can be all y'all on the bass and Spergel.
No, you don't want me singing, but Stefan can play the sax.
Oh, right, we have the sax. I think there might be different musical genre issues, though.
So.
Okay, good. I think that's my section, and I can pass on. Ooh, Shirley plays keyboard.